know how can you do this using processor. We are going to uh, learn more about input output later on, but just want to know that how we can use this delay. If earlier I have told you that must, whenever you study an instruction of a processor, must understand its format, that how many bits or how many memory unit it takes, and also try to understand that which there is a, we can wait for something. Okay ji. My question was that we want to turn on a light of this room, and after some time we want to turn off that light. For example, we want to give a delay of 5 seconds or 5 minutes or 5 microsecond. How we can do using microcontroller? We know that when we are running our instruction, how much time cycle it take. For example, add R16, R17. We should know, as I had earlier told you, that how many cycle it will take. It is taking one cycle. So it is take one cycle. If we are running our processor, any processor on, for example, on 1 megahertz, its clock speed will be 1 divided by 1 megahertz, that is equal to 1 microsecond. So if this instruction takes one cycle, in AVR it takes one cycle, maybe in some other processor it takes two cycle. So understanding an architecture is very much important. In our AVR, this takes one cycle. In most of processor it will take one cycle. It will add two 8-bit values, R16 and R17, will store in R16, and it will take one clock cycle, and that one clock cycle is equal to 1 microsecond if our clock is 1 megahertz. If our clock is more than 1 megahertz, for example, if you are increasing this clock 10 times, your time will reduce by 10 times. So I am making example easy to understand. It is 1 megahertz and our instruction time, one cycle is 1 microsecond. This instruction take 1 microsecond. So if I want to do, and similarly there is a no operation instruction that actually do nothing, just to keep our processor busy. It will take again one cycle, it will again take one cycle, it will again take one cycle. So if these all three instructions take one clock cycle, and here I again use add R16, R17, for example, I am repeating the process. Now this instruction, if it was ran on time t0, then it is t0 plus 1 microsecond, plus 1 microsecond, plus 1 microsecond, and after 3 microsecond this instruction will. So from here to here, after running this instruction get executed after 3 microseconds. So if instead of this instruction I was using the turn on light, and here I'm using the turn off light, it will take 3 microsecond delay. How to turn on light and how to turn off light is about using the input and outputs. We will more for we have already studied about how to send a data over input and output, and using, if you want to turn on the room light, it is working on 220 volt, we have to use some relay or some other things with our IO ports. But for the moment we only want to understand what is delay. Delay is the time period which is used between two instructions or two processes, and it is the time which can be either used by keeping the processor busy in any task that can be useful or cannot be useful. Here I am using the processor or I am keeping the processor busy in a useless task, which processor is not doing anything. Otherwise, you could do also some good work here. For example, you could do some other relevant work or needed work, but for the moment here, no operation. Here you could use add R20, R15, if this R19. General purpose, we have general purpose register from 0 to 31, but for these instructions we used above 16. So here I am using 20 and 17. For example, this is our useful instruction. So one instruction can be replaced here. Processor will take 1 microsecond, 1 microsecond, and then 1 microsecond, 3 microsecond. But no, this is a useful work. This was the unuseful work. It's okay. For example, we want to do unuseful work just to keep busy so we can get some delay. That's okay. But if here we want to increase the delay from 1 microsecond to 1 second, what we can do? Have you understood the question? We want to turn on this light and we want to turn off that light again after 1 second. How can we do that? We have to keep processor busy in, for example, useless thing and for 1 second. If our clock speed is 1 microsecond and our most of instruction, for example, taking 1 microsecond, we need to use unuseful instruction, for example, no operation for 1 mega time. 1 mega is 1 into 10 raised power 6. So we have to use 100,000 times. NOP, 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 no operation, no operation, no operation. So we should need here 10 raised power 6 instructions just to make 1 second delay. Can our processor do this? Our processor might able to do this. It's able to execute instruction, yes, but our memory is limited. Our instruction memory here, if you are writing this instruction 100,000 times, this will get exhausted and you have limited memory. So what we can do? We can use our loops. So first let's make example easy, that we want to make delay of 250 microsecond. So what I will do, LDI R16 200. Here what can I do? Here I had run instruction, now I want to give delay before turn off. LDI R1600, I will decrement R16, then here I will use branch not equal label loop. I'm just writing loop to make it easy. Loop. So this is a 100 value, it will decrement, and unless this value not become equal to 0, it will take jump. When it will take jump 100 times. So this instruction is taking 1 clock cycle. This instruction also take 1 clock cycle, but after this your processor fetch the new instruction. Processor is at 2 pipeline stages: fetch, execute. Fetch, execute, pipelining. When you are executing the new instruction, your processor fetch the next instruction, so it makes your process fast. This is a pipeline, 2 stages pipeline: fetch and execute. What you are doing when you are fetching, you are executing this instruction, your processor fetching this instruction. When you are executing this instruction, it will fetch automatically the next address instruction, your next program instruction. our program counter will be fetch automatically increment, it will fetch this instruction. But now what is happening when it will fetch this instruction, but here this instruction become true and you want to go behind on loop, so you will discard your this instruction, so it will waste your this cycle, and then your this instruction will come from here, so one cycle get wasted. So instead of one, it will actually take two cycles. How? One taken by this, one taken by this. We discarded this every time. So here I have written two. But in last time when this instruction become not true and we needed this instruction, uh, then we will write. So here how many time this will be run? 100 time. This will take 1, this will take 2. So when you are turning off light here you have, let's say, turn on, how many cycle it will take? One clock cycle, one cycle, one cycle and two cycle will be repeated 100 times. So delay would be 1 plus 2 plus 1, 3 into 100, and then you are turning on light. But last time you are, this will take minus 1 cycle because it will take only 1 cycle. So actually this is 1 plus 3 into 99, because 2 plus 1 3, and last time it will take 2 cycle. 1 plus 1, 2 cycle. So you can write in this way, it's easy for you people. 3 multiply by 100, at the end subtract 1 plus 1. So this plus 1 is this one. So 300 times. So here if you have turned on your light and here you are turning off your light, it will take 300 cycle. Now if your processor is 1 megahertz, your clock speed is time period is 1 microsecond, this will become 300 microseconds. If you are increasing your clock, your delay will get automatically reduced. This is the reason we need to understand our assembly language. Your code has not changed, your code is same, only you change your processor speed. So your this all tasks will be done quickly and your light will be start turning on and off quickly, less. And if you are increasing this 10 time, your light speed turning on off will increase 16 time or 10 time, whatever speed you increase it. But let's keep this 1 megahertz and this is 300 microseconds. Now if you want to reduce it or want to increase it to 900 microsecond, what you can do, you simply here change this speed. If you are making it 200, you here will multiply it by 200. 200 by 3 is equal to 600. So 600 microsecond. If you want to make more delay, what you can do? You can only delay here 255 time you can count. What you can do? You can put here no operation instruction. For example, if you are putting one no operation instruction, it will be 4 multiplied by 200. If you are putting 2 NOP instructions, it will be 5 into 200. But again the problem is, if you are writing more NOP, you are just wasting your instruction memory. And you can, if you want to make a bigger delay, what you can do? You can use nested loop, multiple loops. Loops inside loops are called in nested loop. We have already understood those loops. You people have to calculate a delay of 1 second by using nested loops. Assume that your clock speed is 1 megahertz and you want to make a delay, you want to keep your processor busy for 1 second. So when you do something after that 1 second, it will automatically will be delayed. How you will do? You can use multiple or nested loops and you have to calculate the delay. How many time you need a delay? how many clock cycles? You need delay for 1 into 10 raised power 6 clock cycles. So you need to keep busy your processor for this much time. How can you do? You can use nested loops, and whatever value of nested loop or inner loop or outer loop, it is up to you. One is a just rough delay or not accurate delay. There you just simply multiply outer loop and inner loop. Let's say your outer loop is running by 100 times and your inner loop is also running by 100 times. You just only multiply these two and you say, okay, your delay is 100 multiplied by 100, and if there are 3 instructions inside it, just you multiply it with 3. So this is your delay. This is the rough calculation of delay. But if you want exact delay, then you need to count every instruction, that how many time it gets run and how many time it will be executed and how much time it will be take. Remember again, because our process is 2 stages pipeline, it fetch one instruction while executing the other instruction. This branch instructions take one cycle itself, but because if this branch is true, it will go up, it will discard our next instruction, whatever it is. So it is actually taking 2 clock cycles until and unless it become true. Unless and until it become true, it will take 2 cycle, because it take 1 cycle to discard this instruction, then go here. But at the end it will take 1 cycle less, it will not take 2 cycle. I used here 3 because 2 was this one and 1 was for this instruction. Okay, thank you very much. Your task is to again to find or to write a code for 1 second delay when your clock processor speed is 1 microsecond or 1 megahertz is your clock speed. Thank you very much.